Welcome to another lesson on malware detection using data science. In this lesson, we are going to build a classifier using dynamic analysis information. It's going to detect malware as it executes. This time, we're going to go straight to designing a dynamic malware detector. The features we're going to use are API calls. I've prepared a collection of logs of API calls by Android malware and benign samples. Just to show you an example, we see here android.os.systemproperties.get. There's also android.app.context implementation, register receiver, and many other API calls. We want to make sure to create a training testing split. And then the plan is to apply n-gram techniques to the sequence of API calls. So my tokens now are going to be API calls. Each API call is a token, a gram if you wish. And as my features, I'm going to use the most common 2000 n-grams. N here being 3 because if n was smaller, you might underfit, and if it was bigger, it might be a little slow and perhaps will overfit. So we are looking for the most common 2000 triples of API calls. To see a few of these triples, I define a function to featureize a sample, meaning count the number of times each of those most common n-grams occurs in its sequence of API calls. Featureize our training and testing sets. And now I'm going to create a pipeline, which is basically a sequence of operations, which is going to transform the 2000 n-gram features extracted from all the samples into 1000 features derived from mutual information. And then I'm going to train a random forest classifier on top of that. Finally, we're also going to get a testing accuracy, and we can see that the training accuracy is 97% and the testing is 86%. There's a bit of a drop, which is normal but suggests some overfitting. So in a future iteration, if we were to want to improve our algorithm, we would think of ways to decrease the overfit. So this is a basic approach to building a dynamic malware classifier. Take the sequence of API calls and build an n-gram classifier on top of that. And as you can see, it has great potential.